In today's video, I will be showing you how to derive various kinds of problems in calculus using all the differentiation rules we know. After understanding how to derive the provided examples, you will have the confidence to derive pretty much any problem in calculus. I have provided a link to all the formulas you will need in the video description below. Here's the list of examples we will be covering in this video. So let's start with number 1. For the first one, we are deriving cube root of 2 minus 4x. To find the derivative, first we're going to use the chain rule and find the derivative of the outside function. So let's rewrite this. This would be 2 minus 4x raised to the 1/3 power, since in the inside it's raised to the first power and the outside function is raised to the third power, so it's going to be 1/3. Now we're going to derive this function. Okay, so this would equal to, we bring the power down, we have 1/3, 2 minus 4x, to the 1/3 minus 1 power, which is negative 2/3, times the derivative of the inside function, which is negative 4. Now we are deriving 6 plus 2x minus 12x squared raised to the negative 4th power. This would use the chain rule as well, and we're going to bring down the power, and we're going to get negative 4, 6 plus 2x minus 12x squared raised to the negative 4 minus 1 power, which is negative 5, times, now we're going to derive the inside function, and that's going to be, this would be 0, derivative of 2x is 2, derivative of negative 12x squared is, we're going to bring this down again using the chain rule, and we're going to get negative 12 times 2x raised to the first power. So we will get times 2 minus 24x. In our third example, we are finding the derivative of natural log of cosecant x plus cosine of 2x. In order to derive this problem, we gotta know some of the rules. First one is, what is the derivative for a natural log of f of x? Derivative of this would be derivative of the f of x over f of x. Another thing we should know is derivative of the trig functions. So derivative of cosecant of x would equal to negative cosecant x times cotangent x. And derivative of cosine x is going to be negative sine x. Okay, now let's derive. So using the chain rule, first we're going to derive the outside function, which is the natural log function. So first, we're deriving the inside, the f of x, and that's going to be derivative of cosecant is negative cosecant x times cotangent x plus derivative of cosine is negative sine of 2x. Now we're going to derive the inside function, which is 2x, and the derivative of that is going to be 2. So here we got this part, derivative of the function inside. Now we're going to divide this by the function itself, plus cosine 2x. The rest will have to be simplified. Now let's move on to the next example. In the fourth example, we are deriving 2 times cosine of 7x squared plus cotangent x. To derive this, we gotta know two formulas, which is derivative of cosine, which is negative sine, and derivative of cotangent, which is negative cosecant squared x. Now let's find the derivative. This would be derivative of cosine, which is, we pull the 2 out first, and then we find the derivative of cosine, which is negative sine of the same function, 7x squared, plus cotangent x, times derivative of the inside function, which is, using the chain rule, this will be 7 times 2x to the first power, plus derivative of cotangent is going to be negative cosecant squared x. The rest will be simplified. Let's find the derivative of 5 times e raised to the 1 plus sine x power. To derive this, we gotta know the derivative of an exponential function. Derivative of e raised to the function, would it be equal to derivative of the function times e to the f of x? So we're gonna get, first let's pull out the constant. It's gonna be 5 times derivative of 1 plus sine x, which is derivative of sine is cosine, times e to the 1 plus sine of x. Now we're finding the derivative of secant of 5x. Derivative of a secant function is secant x times tangent x. Now let's find the derivative using this formula. So this would equal secant of 5x times tangent of 5x. Now, the last part we're going to multiply by the derivative of the inside function, which is 5. In this example, we are deriving 3 raised to the power 1 minus 7x. The derivative of a general exponential function, let's say a to f of x, derivative of this would be a raised to the power of x times derivative of f of x times natural log of that constant. Now let's derive this problem. So this would equal the same function times derivative of the power, which is going to be negative 7, times natural log of the constant. In this example, we are deriving natural log of cubed root of 2x plus 7 over 3x squared. So let's do it step by step. First, we know that derivative for a natural log function is derivative of the inside function over the function itself. And before deriving this expression, let's first simplify it. So we have derivative of natural log. Now, cubed root, let's raise the function inside to 1/3 power. So we could write it this way. So there's a rule for natural logs where it says that natural log of x raised to a power 5. This power could be brought up out of the function. So we will get 5 times natural log of x. So in this case, we could take out the 1/3 to the front, 1/3, and we're going to have the rest here. Okay, here we only simplified it. We did not find the derivative yet. Now we're going to find the derivative. So now that the 1/3 is taken out, so now we're only working with the function inside. So derivative of that function is going to be using the quotient rule. In the quotient rule, we know that first we have to find the derivative of the numerator, which is going to be 2, times the denominator, minus derivative of the denominator, which is going to be 3 times 2x, which is 6x, times the numerator, 2x plus 7, over the denominator squared, 3x squared squared. Now this would be divided, now that we found the derivative of the function, now we're dividing by the function itself, which is 2x plus 7 over 3x squared. So first, to go over, first we simplified the function by using natural log rule, where when we have a natural log of a function raised to a certain power, we could bring that power to the front as a constant. So that's what we did in this case. We bring out the 1/3 to the front, and now we're going to derive. Now we brought the 1/3 out of the function. Now we're deriving the inside function, which is this thing, and then we divide by the function itself, which was 2x plus 7 over 3x squared. In this example, we are finding the derivative of an inverse function, which is inverse of cotangent of 5x minus 2. To derive this, first we need to know what's the derivative of an inverse cotangent. Derivative of an inverse cotangent function is -1 over 1 plus x squared. Now let's find the derivative. So this would be -1 over 1 plus x, in our case, is going to be 5x minus 2 squared. Now that we found the derivative of the inverse cotangent, now we're finding the derivative of the inside function, which is 5. Now let's move on to the next example. For this example, we're deriving sine of 2x times cosecant of 5 minus x squared. Now let's go over some of the formulas. Derivative of sine is going to be cosine. Derivative of cosecant is going to be negative cosecant of x times cotangent of x. Now let's find the derivative using these formulas. Well, first let's notice that we have a product here, so we're going to use the product rule. So first we're finding the derivative of the first function, sine of 2x, which is going to be cosine of 2x times the derivative of the inside function, which is 2, times, using the product rule, the second function, which is cosecant of 5 minus x squared, plus derivative of the second function, which is negative cosecant of 5 minus x squared, times cotangent of 5 minus x squared, times derivative of the inside function, which is negative 2x, times the first function, which is sine of 2x, using the product rule. The rest is simplification. In this example, we are deriving 3 minus e to the negative 5x over x squared plus cotangent of 10x. First, let's go over the rules. So derivative of an exponential function is going to be derivative of the power times the function itself. And then the derivative of a cotangent trig function is going to be negative cosecant squared x. Now let's derive this. So here we're going to use the quotient rule. So we're finding the derivative of the numerator first, and we get, let's pull out the negative, and derivative of the power is -5 times the function itself. Now using the quotient rule, we'll multiply this by the denominator, which is x squared plus cotangent of 10x, minus derivative of the denominator, which is going to be 2x, plus derivative of cotangent is going to be negative cosecant squared of 10x, times derivative of the inside function, which is 10, times the numerator, which is 3 minus e to the negative 5x, over the denominator squared. The rest will have to be simplified. For example number 12, we are deriving sine of x cubed times e to the 5x. Let's start with the rules. Derivative of a sine function is going to be cosine of x, and derivative of an exponential function is going to be derivative of the power times the function itself. So let's find the derivative. Derivative of sine is cosine, so we're going to get cosine of x cubed times e to the 5x times, now we're finding the derivative of the inside function, which here we see that we need to use the product rule. So we're going to get derivative of x cubed, which is 3x squared times e to the 5x, plus derivative of e to the 5x, which is going to be derivative of 5x, which is 5, times the function itself, times the first function, which is x cubed. The rest is simplified. In this example, we are deriving tangent raised to the power 7 of x raised to the power 4 minus 2. So first, let's go over the rules. Derivative of tangent x is going to be secant squared x. Now let's find the derivative. So first, let's start with deriving the outer function, which is going to be the power 7. We're going to bring that down, and we're going to have now tangent raised to the 6th power of x4 minus 2. Now we'll multiply by the derivative of the tangent function, which is going to be secant squared of the same function inside, which is x4 minus 2. Now we'll multiply by the derivative of the very inner function, which is going to be 4x raised to the cubed power. So as you see, first we're deriving the very outer function, which was the power 7. Then we're deriving the inner function, which is tangent function. And then we're deriving the very inner function, which is x4 minus 2. For example number 14, we are deriving log with base 5 of 4x squared over 2x minus 1. Let's go over the rules first. Derivative of a logarithmic function with base b would equal to the derivative of the function, derivative, over the function times natural log of the base. Let's use this formula to find the derivative. So now we're going to get the derivative of the function inside, which is going to be, we're going to use the quotient rule to find the derivative. So we're going to get 4 times, we're using the chain rule, we're going to bring the 2 down. We're going to get 2x times the denominator, 2x minus 1, minus derivative of the denominator, which is 2, times the numerator, 4x squared, over denominator squared. Okay, in this case, we only found the derivative of the function. Now we're going to divide this by f of x and natural log of the base. So we will have divided by 4x squared, 2x minus 1, times natural log of 5. So to rewrite this, we're going to have all of this rewritten, 8x squared over 2x minus 1 squared. Now division, could be turned into multiplication, by switching the denominator and the numerator. So for the numerator, we're going to have 2x minus 1, and denominator is going to be 4x squared times natural log of 5. There we go. The rest will be simplified. In this last example, we are deriving the inverse of sine of 5x minus natural log of x to the 4th power plus 2x, all raised to the negative 5th power. Let's start with the rules. First rule, the derivative of an inverse sine function is equal to 1 over square root of 1 minus x squared. Now, derivative of a natural log function is derivative of that function over the function itself. Now let's use these rules to find the derivative. Okay, first we'll have to find the derivative of the outside function, which is this power, using the chain rule. We're going to bring that power down. We're going to copy everything inside. And we're going to raise it to the negative 5 minus 1 power, which is negative 6. Now we'll multiply this by the derivative of the inside, which would be derivative of inverse sine is going to be 1 over square root of 1 minus 5x squared. Now we'll multiply by the derivative of the inside function for that inverse, which is 5, minus, now we're going to derive the second function. And we're going to get derivative of the inside, which is 4x to the cubed power plus 2 over the function itself, which is x to the 4th plus 2x. That's it. And the rest would be simplification. If this was helpful, please subscribe to my channel. See you in my next video.